Covering approximately two-thirds of the planet's surface and host myriad life forms, oceans are a critical component of the global ecosystem. Sometimes referred to as the evil twin of climate change, ocean acidification is an increasingly publicized field of environmental studies discovered about 15 years ago. With predominantly negative attention, one might begin to wonder, just what is ocean acidification? Is it really that bad? And should we be doing anything about it? Like climate change, ocean acidification is the result of excessive carbon dioxide in the Earth's atmosphere, which eventually settles in ocean waters. According to the Smithsonian, global oceans have absorbed about 525 billion tons of CO2 from the atmosphere, which equates to around 22 million tons per day. Originally, scientists had hoped this absorption would be a positive offset to anthropogenic pollution, slowing or reducing the severity of climate change. And though it has also resulted in a change to the chemical balance of ocean waters, leading to the decreased survival, development, and abundance of some marine ecosystems. Though the term ocean acidification might conjure up images of boiling, burning seas, scientists believe ocean waters will not move below the neutral pH level of 7. Still, oceans have dropped from 8.2 to 8.1, constituting a 30% increase in acidity across the last century alone. So what does more acidic waters mean for marine ecosystems? Croker and others are finding mixed results. Some species flourish in less alkaline waters. Crustaceans appear to grow thicker shells, jellyfish become dominant, and some seagrasses develop faster. Other species, especially those relying on calcium carbonate to build shells or skeletons, such as mussels, oysters, and corals, diminish in more acidic waters, as the chemical compounds necessary to establish strong shells are no longer present. For example, after 45 days exposure to increased acidic waters, a pteropod shell has almost completely deteriorated. Fish appear to manage well with growing larger, though some show neurological warning signs of becoming confused, have trouble navigating, and have decreased detection of predators owing to impacted hearing. Part of the problem in knowing the full implications to marine ecosystems is the lack of holistic, long-term data. Though meta-analyses indicate the outcome for marine life is predominantly adverse, individual studies have focused on specific species in limited locations, which doesn't account for localized adaptation or acclimatization, or consider influencing or causal factors such as pollution, ocean warming, and overfishing. This means that without more time and an understanding of the complex relationships between factors which affect marine life, we cannot yet fully understand the implications of ocean acidification. What is clear, however, is that if CO2 pollution was reduced to a manageable amount, oceans are likely to remain more acidic for some time, possibly thousands of years, and the damage may be too deleterious to save some marine life. Without a dramatic decrease in emissions, the problem is likely to become significantly worse. Beside emission reduction, additional actions are debated by scientists, with most agreeing further research is required. Though discovered 15 years ago, ocean acidification is in its scientific infancy, and we have a lot more to learn. Until then, think of the oceans and cut your carbon.